of the solution is 3.2 kilogram per liter. So what we can do here is to plug the 3.2 to here. And then okay, let's do some math for fun. Today I'm going to talk about a problem about the one of the application of first order differential equation, which is the mixing problem. A tank contains 10 kg of sodium hydroxide in 1000 liters of water. Water is added to the tank at the rate of 5 liters per minute. At the same time, the solution flows out at the same rate. Find the time taken for the concentration of the solution, which is 3.2 gram per liter. And as always, if you guys are interested in this video, pause the video and try them for yourself. Okay, so let's define a differential equation from this problem. Now remember, when we talk about a mixing problem, we must remind this formula, right? Which is dA over dt, where A is the amount of a substance and T is the time. So we must remind the formula. dA over dt is equal to the rate of the substance going in minus the rate of substance going out. And if you guys memorize the formula, right, you will have another thing that is going on in each of these terms. But don't worry, we will go in one by one. Now, dA over dt is equal to the rate of a substance going in minus the rate of substance going out. So and this we still can like separate, which is equal to the rate of a solution going in, the rate of solution going in times the concentration of the following substance minus the same thing as here, similar, minus the rate of solution going out minus not minus, it's times the concentration of the substance going out. And then here's what we're going to do. Now I will rewrite this here, dA over dt and dA over dt. Now the rate, now what we're going to do is the rate of solution going in. What is the rate of solution going in? Now, and I almost forgot one thing. The units that we need to measure are about A and the T. Now I will let A measured in kilogram, and I will let the time measure in minute. Now here's what you're going to do. Now dA over dt is equal to the rate of solution going in. So what is the rate of the solution going in? 5 liters per minute, right? Because water is added to the tank at the rate of 5 liters per minute. So this is our unit. So 5 liters per minute times the concentration of the sodium hydroxide, because in this case our substance is going to be sodium hydroxide. What is the concentration of sodium hydroxide going in when it's going in? It's 0, right? Because only water is added to the tank. which means there is no sodium hydroxide mixing with water and going into the tank, which means that the concentration of the sodium hydroxide is going to be 0. So we want to divide by 0 minus the rate of solution going out. So why is the rate of solution going out? It is still the same thing because the solution flows out at the same rate. So we will have 5 times the concentration of the sodium hydroxide going out. So what is the concentration of the sodium hydroxide going out? Actually, we don't know, but we can try to express with variables because at the same time the solution flows out at the same rate. So when we talking about the concentration of substance going out, remember how do we find the concentration of something? So the concentration of something is equal to the amount divided by the volume, where the amount is referred to the mass, right? So here's the thing. Now, amount divided by volume, this is the concentration. So in order to find the concentration, it's going to be amount divided by volume, which means that in this case it's going to be the amount of the sodium hydroxide, which is A, divided by the volume in the tank, which is 1000 liter. So 1000. Now, and then 5 times 0 is going to be 0, and our 5 times 1 over 1000, that's going to be 200. So dA over dt is going to be negative A times 200. And this is very easy to solve because it is separable. So
we will have A going to here and dt going to there. So we will have 1 over A dA is equal to negative 1 over 2000 times t. No, times dt. And then since we got the differential operator at both sides, which means we can integrate. So the integral of 1 over A dA is going to be the natural log of absolute value of A is equal to the negative t over 200 plus c1. And then I will take this equation to the other side, and then cancelling the natural log, which will have the Euler's number E as the base at the other side. So the absolute value of A is going to be equal to E to the power of negative t over 200 plus c1. And then we can use the law of indices to separate this. So E to the power of negative t over 200 times E to the power of c1. And now c1 is a constant. So E to the power of c1 is still a constant. So we will let this equal to c2. So absolute value of A is going to be c2 E times E power of negative t over 200. And then we cancelling the absolute value, which will lead to plus minus at the other side, and plus minus c2. C2 is a constant, which is plus minus c2 is just basically another constant. So we will have c3. And that is the final solution. And we write the equation again. We will have A is equal to c times E to the power of negative t over 200.
And here's what we can see. Now, a tank contains 10 kg of sodium hydroxide in 1000 liters of water, which means that initially the tank contains 10 kg of sodium hydroxide, which means that A of 0 is equal to 10 because measured in kilogram, remember. So we will plug this. So this is the T, this is the A. We can plug in T to here and then A to here. So 10 is equal to C times E power of negative 0 over 200. And then this will equal to 1. So C is equal to 10. Then we plug in the 10 to the C. So A is equal to 10 times E to the power of negative T over 200. And this is the particular solution for the following differential equation. And have we done? No, we haven't done yet. Remember, find the time taken for the concentration of the solution until it reaches 3.2 gram per liter. And remember the concentration formula. It's equal to amount divided by volume, where the amount refers to the mass. So our strategy to solve this problem is we need to find the amount of sodium hydroxide when the concentration reaches 3.2 kilogram per liter. So A over 1000 is equal to 3.2, and we have to use our mind to match the unit. So where A is measured in kilogram and 3.2 is measured in gram. So we have to divide by 1000 to convert into kilogram per liter, because 3.2 gram per liter is same as 3.2 over 1000. Maybe it's too messy here. Okay, 3.2 gram per liter is same as 3.2 over 1000 gram per not gram per liter, it's kilogram per liter. But I want A in kilogram, so that's why I have to convert gram per liter to kilogram per liter. And then what we can see is A and 1000 cancel, so our A is going to be 3.2 kilogram, which means that when the amount of sodium hydroxide is 3.2 kilogram, the concentration of the solution is 3.2 kilogram per liter. So what we can do here is to plug the 3.2 to here. And then we are going to solve for T. So which is 3.2 divided by 10, which is 0.32, and then put E to here, which will result a natural log. So I will rewrite this again: 0.32 times the natural log of this thing, and then which will remain negative T over 200, and we can multiply negative 200 to the other side, which will result negative 200, and then this is our T. And remember, negative 200 times natural log of 0.32, that is measured in minutes. But if you want to convert it to hour and minute, it is going to be approximately equal to 3 hours and 48 minutes. And this is our answer to the problem. So yeah, so this is quite messy, but in the end we still can find out the solution. And as always, if you guys learn something new in this video, leave a like and subscribe to the channel, and I will see you guys next time.